This video is meant for Thursday, July 20th for Math 1332. We're going to be covering two sections today, sections 2.4 and 2.5, and that will complete the first week of learning new material, and we'll have finished 8 sections for this week. And that's what the first test covers, is the 3 sections from chapter 1 and the 5 sections from chapter 2. Okay, so 2.4, luckily there's nothing new in 2.4, it's just an extension of 2.3. We're now going to have 3 variables at once. There'll be a set A, B, and C all going on at once, and they had A, B, and C in the previous section, but they always did them 2 at a time only. Now it can be 3 at a time, and they'll do some problems where they just give you sets, and then they'll do some with Venn diagrams too. So that's kind of like the assignment has half where they list the sets out and half where they do Venn diagrams. So 2.4, set operations, and then Venn diagrams with 3 sets. So 15 problems here. Okay, so we're given our universal set as usual is right here, 1 through 6. A is just arbitrarily 1, 2, 4, and 5. B is 2, 3, 4, and C is 1, 2, 3, 4, 5. And then they want me to do A union parenthesis B intersection C. So problem number 1 of section 2.4. There's a universal set of 1 through 6. And then we have 3 different sets, set A, set B, set C. I remember C was 1 through 5. And then A and B are just some of the numbers. A's 1, 2, 4, and 5. And B is 2, 3, 4. And this is just all regular. They could have added some of those apostrophe ones where you're doing the complement or not that it happens. And that's probably coming later here in a minute, but for this first one, they just have A union B intersection C. And once you have 3 of them going on, they'll usually put parentheses around 2 of them then. And if they don't, then you just travel left or right. But if there's parentheses, that allows us to change the order up so that it's not just left or right. Maybe I want to do the last 2 before I do anything else. So I would put parentheses around that. So B intersection C, you just do this parenthesis part like section 2.3. This part right here is literally just section 2.3. So intersection, that's when you want to find what these 2 things have in common with each other. What numbers are in both set B and set C. B and C, they both have a 2. They both have a 3. And they both have a 4. So B intersection C, the answer to that alone would have been 2, 3, 4 if I was doing this in section 2.3 like last time. So here's all that's different is now I'm going to bring down set A, and that's right here, 1, 2, 4, and 5. And then you just start over again and now do a union between these 2. And it could have been another intersection, but it happens to just be a union. So 1 was an intersection, 1 was a union. They could have both been intersections or both been unions. It's all pretty arbitrary. They're just making stuff up as they go. So you just have to constantly be ready for either rule that could come up. Now I want 1 of each item without any repeats. And again, the way I do that is I take the bigger looking one. This one's size 4, the other one's size 3. So all the numbers from the bigger one are definitely going to be in the answer of a union. 1, 2, 4, and 5 have to be there. Then I go to the smaller one, and we already got the 2, we already got the 4, we don't have the 3 yet. So let's insert the 3 in here. And then again, you never want repeats in like a final answer, even though it's not wrong if you do, but it just makes it too confusing. So the general rule of thumb is never put repeats in your answer, and then try to put the answer in order too. That it just helps everybody. So it turned out I was left with 1, 2, 3, 4, 5. So you're just basically doing what you did in section 2.3 2 different times in one problem. 1, 2, 3, 4, 5. And now they just reversed it. Now they have the intersection on the outside and the union on the inside. So we'll do the union first this time, and then we'll do the intersection second. Because of the parentheses, that always tells me which one to do first. And then, of course, they changed all these up too, although C is still the same. But the universal set, A and B, they're different from before. So the universal set on number 2 is 1 through 10. And they kept set C as 1 through 5. And I'll write that out just because we might need to look at it individually. Set A is 1, 2, 3, and 6. Set B is 1, 2, 3. We want to do A intersection, parenthesis, B union C. And we got to do the parenthesis first. So B union C, that means I need one of each of those. And C is the bigger looking one out of those two, so definitely everything in C is going to be in this answer. 1, 2, 3, 4, 5. Set C is a size 5, set B is only a size 3. So I grab one of each from the bigger one, and then go back to the smaller one and get anything else I don't have yet. But the smaller one only has 1, 2, 3, and I already have all 3 of those, so we never put repeats in the answer. So I don't need anything from B. B union C, in essence, is the same thing as C, because C already has everything that B has. But if, say, B was like 1, 2, and 7, then I would include a 7 over here, because C didn't have the 7. And then I'm just going to rewrite A right here, 1, 2, 3, and 6. So now we need to do an intersection between these two. And an intersection is, what do they have in common? So from A's set 1, 2, 3, and 6, and then this answer I just got of 1 through 5, what do those have in common? Well, they both have a 1. They both have a 2. They both have a 3. But this one's got 4 and 5, and this one's got 6. Those are singletons, so the only repeats are 1 through 3. So basically an intersection is the repeats out of the 2 sets you're looking at. So this final answer will be 1, 2, 3. So those were 2 similar problems, just kind of backwards. So now they're going to make me do this 3 times. I've got 2 sets of parentheses. And then when that happens, you just do those in order. So you should do A union B first. Then do A union C second. And then once you get those 2 answers, then the last thing you're going to do is an intersection of them. So we need to get an A union B, an intersection with A union C. And then we'll have our usual universal A, B, and C sets given to us. Okay, so universal is 1 through 9. It's been different every problem so far. We had a 1 through 6, a 1 through 10, and now a 1 through 9. A is 1, 2, 4, and 6. B is 7, 8, 9. And C is 1 through 5. I don't know why they keep doing 1 through 5 for that one, but okay, 1 through 5. So A union B, I'll do that one in purple first. A union B, we need one of each thing from A and B. So I need a 1, a 2, a 4, and a 6. All those are going to be there because that's the bigger looking one, the bigger size set. Everything from the bigger size set is always in a union answer. Then I go to the smaller one and include anything I don't have yet. I don't have a 7, I don't have an 8, and I don't have a 9. So last time we did a union, the set B, the smaller one, didn't contribute anything to the answer. Now everything B had got contributed to the answer. Okay, A union C. So C is the bigger one. 1 through 5 is definitely going to be in the answer. And then I go to the smaller one, A, and we already got 1, we already got 2, we already got 4, but we don't have 6. So we need to include 6 as well. So I did A union B and got 7 answers. I did A union C and got 6 answers. And now we want to do an intersection between those. So what do these two answers that I just came up with, what do these two have in common, if anything? They both have a 1. They both have a 2. They don't both have a 3. But they do both have a 4. They do not both have a 5. But they do both have a 6. And then 7, 8, 9 are singles as well. So only 4 things remained in the answer for the final answer because that's the stuff that these two purple answers had in common. 1, 2, 4, and 6, which happens to be what A is, but that's sometimes just a coincidence. 1, 2, 4, and 6. Here they come throwing in the apostrophes for the first time. So A apostrophe, or what we call not A, intersection, and then in parentheses, B union not C. So the A has been, this is called negation when you put a not on it. We've done a negation of the A and we've done a negation of the C, but B is going to stay regular. So when I get a problem like number 4, first I'm going to write down all 4 of the sets. And then for any of the ones that have the apostrophe, then I'm going to do them right away before I do anything else. So the universal sets 1 through 7. Set A is 1 through 4, but I'll write it out. 1, 2, 3, 4. Set B is 1, 2, 3. And set C is 1, 2, 3, 5, and 6. And we don't need the negation of B, just A and C only. So since universal sets 1 through 7 and A's got 1 through 4, what does A not have? It doesn't have the 5, the 6, or the 7. And notice that A is a size 4, not A is a size 3. 4 plus 3 is 7. The universal is a size 7. So that anytime you do A and not A, the sizes of both of those should always add up to the size of the universal. If I'm going to do C and not C, then this one's a size 5. This better be a size 2, so that way it'll add up to 7. So we got 1, 2, 3. We don't have 4. We got 5 and 6, but we don't have 7. See, size 2. So before I even try to do anything that the problem actually wanted, I always, if there's negations, I just do them right away. I know I'm going to need a not A at some point. I'm going to need a not C at some point. The knots are generally easy to do, so I just get them out of the way. Even if I didn't need it right away, I would just do that right away. So I got to do this parenthesis first. Let me write down the whole thing. It's A, not A, intersection, parenthesis, regular B, union with not C. So we want to be looking at not C plus regular B. Those are the two to just look at right now. Out of these two, we're either going to grab one of each or what they have in common. This is one of each. So that's it. You kind of got to memorize it. When do you want the common stuff? When do you want one of each? And one of each is literally one of each because they don't have anything in common. 1, 2, 3, 4, and 7. So if you grab the bigger one first, write down all those 3 things, then go to the smaller one and add 2 more things to it since we don't have either of those. And so now I'm going to use this not A right here. Not A is 5, 6, 7. And I'm going to compare that to 1, 2, 3, 4, and 7. And I'm going to do it in an intersection. What do those two have in common? Really well. Okay. So they don't both have a 1. They don't both have a 2. They don't both have a 3 or a 4 or a 5 or a 6. The only thing they have in common is 7. So often intersection answers are smaller in size than union answers. Union answers are usually larger and intersections usually smaller. Occasionally they're equal, but usually they're different. And I almost didn't catch one. It was the very last number that they had in common. So imagine if that hadn't been true, then I could have had no answer at all. If you don't have anything in common, that's when you say empty set. That almost happened to me here, but there was one lonely number at the end that was the only number they both had. Okay, so now they put all 3 of them in a parenthesis, A union B union C, and then the apostrophe on the outside. So whenever the apostrophe is on the outside, you have to do the inside first. This is where I would not do the negations right away. So we got our universal set, set A, set B, set C. They want me to do A union B union C. And then once I get that answer, then we'll do the not and negate it. So the universal is just 1 through 6. I'll write this all the way out since it's short. 1, 2, 3, 4, 5, 6. A is 1, 3, 4, and 5. B is 1, 2, and 4. C is 2 through 6. Okay, so out of all 3 of A, B, and C, the A is a size 4, B is a size 3, and C is a size 5. So out of the union, I would grab all of the biggest one first. So everything in the biggest answer, or the biggest set, I mean, the entire set from the biggest one is always in a union answer. So I always write the biggest one down first. For sure, I'm going to have all those in the answer. Then go back. Normally you just go back to the smaller one, but now we have to go back to both of the other ones. And I need to include anything I don't have already. So I don't have a 1 yet. I need to include that. I already have a 3, a 4, and a 5. And then I would go to B, and in theory I could get something extra that I don't have yet from B, but I already have 1, 2, and 4. So C almost contained everything. In fact, C contained everything except for 1 out of the universal set. And then if you go between A, B, and C, between all three of them, they have one of every number that's in the universal set. So it turned out A union B union C was literally the universal set in this problem. So now I need to negate it. So what does this answer have? Or I'm going to say it this way. What does the universal have that my answer doesn't have? That's what the negation would literally mean. What does the universal have that my answer does not have? Well, nothing. Because all 6 that I have, so does the universal. So if you ever have the entire universal set as an answer at any point, and you want to negate it, what are you missing at this one? I'm not missing anything, so that's the empty set. And that's how you get an answer that is the empty set, when you just can't write any answers down. So in the homework, you just click that option. There's no way to write that, but you just say empty set by clicking it. Okay, so now they have a parenthesis around A union B, then an apostrophe on the outside, and then intersection C. A union B, do that first, then negate it, and then intersect with C. Universals 1 through 9. Set A, B, C. A is 1 through 4. B is 3, 6, and 7. C is 1, 2, 6, 7, 8. So A union B, this is where I need one of each out of those two. One of each. And I always do it by grabbing the bigger sized one. A is the bigger sized set out of those two. So I'm going to write down everything from set A, 1, 2, 3, and 4. Then I go to smaller one B, and I already have the 3, so that doesn't help, but I don't have the 6 or the 7. I need both of those. And now we want to negate that. So that's when you compare from 1 through 9. What does 1 through 9 have that this answer doesn't have? Well, this answer has 1 through 4. It doesn't have 5. It's got 6 and 7, but it doesn't have 8 and 9. And again, 1 through 9 is clearly 9 numbers. The answer I got in purple had 6 answers, and then the negation has 3. That's always what happens. 6 plus 3 equals 9. So now I want to take this green answer. The green answer is this much of the problem. And now I need to do an intersection with regular C, this right here. So in order doesn't matter. You can do the C in the front or the back. It's either way, it doesn't matter, because you're just looking for either one of each or what they have in common. This is when you're looking for what do they have in common. So they both do not have a 1. They don't both have a 2. They don't both have a 5 or a 6 or a 7 or a 9, but the one number they do both have is 8. So once again, I almost got the empty set, but at the very last minute, I got one number in common. So that's the final answer, 8. Just the set 8. 8's the only thing they have in common. Okay, 7, same kind of problem. It's just they put letters instead of numbers, which makes it a little harder. So the universal set is the letters A through H, which is the first 8 letters of the alphabet. So we got A, B, C, D, E, F, G, and H. Set A is B, D, and H. B, D, H, which is a size 3. Set B is also a size 3, but different 3. It's got, well, one of the elements is different. A, D, and H. And then C is the largest in size. It's got 5 elements. A, C, E, F, and G. A, C, E, F, G. The problem wants me to do A, not A, intersection B. In parentheses, union, and then there's another intersection with both not A and not C. Not A, intersection, not C. So for individual negations, I have a not A and I have a not C, but there's no not B anywhere, so then we don't need to get that one. In theory, somebody could just write all the nots down right away if they wanted to, but I only do the ones that we need, so we don't need not B. There's no point in doing that one. So with the letters, it's a little harder, but A's got B and D, but it doesn't have A or C. And since A's a size 3 and the universal size 8, this better have 5 answers in it. Okay, then I got H, which is the last letter. So I'm missing everything after D, E, F, and G. See how that's got 5? C is a size 5, so the not C should be a size 3. It's got the A and the C, but it doesn't have B or D. It's got E, F, G, and then it doesn't have H. So let me do, well, we should probably do this in order. I was going to do these two since they're right next to each other, but let's do this not A. Let's do that with regular B. So I put 2 green boxes around the 2 I'm concentrated on right now, these 2 over here. And this intersection means what do they have in common? So out of A, D, H, and A, C, E, F, G, what do they have in common? They do both have an A. But C, D, E, F, G, H, everything else is single. So the only double is A. So if this first parenthesis was the whole problem, which it was last section in section 2.3, but now it's just part of a problem in section 2.4, if this was the whole problem, the answer would just be the set A. Okay, now do not A. I'm doing it in purple this time. Not A and not C. Out of these 2, what do they have in common? Because this is still an intersection. What do they have in common? Well, we got a single A, a single B, a single C, a single D, a single E, a single F, a single G, and a single H. Everything happens once and only once. There's no repeats, no duplicates. So this answer on its own is the empty set. So finally, I'm trying to do a union between a set that has 1 element and a set that has nothing. And whenever you're doing unions, you want 1 of each, but another way of thinking about it is you want to write the bigger sized one down first. So I would definitely write A first, because that's the bigger sized one. And then I'd go to the smaller one, which is the empty set, and grab anything I don't have yet. Well, the empty set doesn't have anything to give me, so I can't add anything else. And this was one of the ones we did last time too, is if in general you have any set and you do a union with the empty set, the answer is the any set. So if I do this as my any set and union it with the empty set, it's just going to be itself, in other words. You might have remembered that rule and not had to take as long as I did, but either way it's fine. So it turned out, again, just one element in the answer. It's a size 1 answer, but it's not that you always have to get a size 1 answer, but it's happened a few times already. Okay, we did this exact problem a little while ago, except now it's got letters instead of numbers again. So we need to do A union B union C. I need to grab one of everything that's unique to all of those, and then I'm going to negate it at the very end. Again, the universal set has the first 8 letters of the alphabet. Number 8. Universal set is A, B, C, D, E, F, G, H. Okay. Set A is C, F, and G. C, F, and G. I don't know why that line just kind of randomly flew across the screen. B is A, F, and G. A, F, G. And then C, A, B, D, E, and H. A, B, D, oops, I put D here. A, B, D, E, and H. So if you're doing the inside first, A union B union C, before you get to the negation part, this inside part first is one of everything. And I would write down the entire biggest set first. So for sure, A, B, D, E, and H have to be in the answer no matter what, because that's the biggest one. And then just go to the other two one by one and grab anything you don't have yet. I don't have a C yet, so I got to add that in here. I don't have the F, I got to add that one. I don't have the G, got to add that one. And then I'm over here. A, we already have that. F, we already have that. And G, we already have that. So now my answer for the inside part has 1, 2, 3, 4, 5, 6, 7, 8. So in other words, it's the whole universal set again. By pooling together all the stuff from A, B, and C without writing any repeats, I was able to produce the universal set. And the negation of the universal set is the empty set. The opposite of everything is nothing. So that happened on this same problem. We had a number problem too. It's not that that always happens, but for some reason that happened again. Okay, so this homework has 15 problems, and the first 8 were all similar. Just some had numbers, some had letters, but it was just doing 3 at the same time. We're in essence now switching to the second half of this section, the second topic of this section, which is basically the same stuff, except it's from a Venn diagram instead of from listing them all out. And worst come to worst on some of these, if they get complicated ones with like 3 sets going on at once, you could actually do what you did on the first 8. You could just write down what set A has, what set B has, what set C has, and then do the same rules you did on 1 through 8. But often with Venn diagrams, you can often get answers just by looking at the picture without having to do all that work. And that's the advantage of them. A picture is worth 1,000 words sometimes. And sometimes you can get the answer much quicker just by looking at a Venn diagram, which is why they're so useful. Let me go ahead before I forget and do my magic word of the day. So today is Thursday. This is your 4th one of the week. If you send this one to me along with the other 3, you'll get 100 for this week for that last 10% of your grade. And we've kind of had a similar theme all week long, so I'm going to stick to that one more time, and then next week there'll be an entirely different theme. So yesterday's video had something to do with most people's favorite former planet, so let's do another thing a lot of people find interesting out there. This is most people's favorite object, just kind of floating out there, which will send me an email and just put in the subject, put Thursday, July 20th, magic word of the day, and then the magic word, actually it's a 2-word thing, Black hole. Black hole. So a lot of people like those out there, and they're kind of mysterious, so it fits the theme of the week. Black hole is the last magic word of this week. Okay, so it says list the regions that represent C. C, you just trace all the way around the letter C circle. Even if it goes into other circles, that's okay. There's a difference between just saying the letter C and if you put the word only C. If it's only C, then you're in this white part where you're not touching any other circle. But if they just say C, they got to have the word only for that to occur. So if it's just set C, then you want to go all the way around that entire circle, even if it goes into other circles. And they're doing Roman numerals here for whatever reason. And again, we don't want to put repeats if that ever came up. We don't have any repeats here, but never put repeats, and then try to put the answers in order. So the Roman numeral 4 would go first, then 5, then 6, and then 7. And you just put IV, comma, V, comma, VI, comma, VII. That's 4, 5, 6, and 7 in Roman numerals. Okay, so we actually saw this last time. If you get A intersection B in a Venn diagram, A intersection B when there's only two circles, the intersection is this little middle wedge right here that looks like a football, American football shape. That's the intersection. The union is when you do one of each, literally. Remember, see, this is what they have in common, and union is one of each. So I need this only A part, I need the part they both have, and I need the only B part. So all three sections of the circle is a union. And even when you throw a third circle into the situation, it doesn't really matter. For A union B, you want to travel anywhere circle A or circle B is circling. So it's kind of like this. I'm making a rectangle around it right now. All of those numbers. So if you know A intersection B is this football shape here in the middle, and then A union B is all the way across anything that circle A or B touch, even if it goes into circle C. So that's the short way of doing this. And then in order it'd be 1 and 2, 3, 4, 1, 2, 3, 4, 5, and 6. All of those are at least in A or B. And if you can do this just by looking at the picture, that's what they hope you can do. But if it's get it right on a test, another way to do this slower is to just list all the way around circle A like we did on the previous problem. Circle A is right here all the way around it. Circle A would be 1, 2, 4, and 5. And I'll write them in regular numbers because they go quicker. 1, 2, 4, and 5. And then if I go all the way around circle B, like this, that would be 2, 3, 5, and 6. And then you want one of each. So if it's one of each when both of them are the same size, then you just grab either one you want to start with. So if I write everything in set A first, since it's also a size 4, and then I can go to set B and add things we don't have already. We don't have 3, and we don't have 6. See, 1, 2, 3, 4, 5, 6. So it's really the same thing you've already learned. It's just supposed to be done more easily with a picture. If you can see it in the picture, you don't have to do all that. But if you're ever in doubt, write out what the two individual sets are, what goes all the way around them, and then use your rules about do you want what they have in common or one of each. And I got 1 through 6 quicker, but I can get it slower too. Here's B intersection C. So that's not all the way around circles B and C. That would be B union C. B intersection C is this little football wedge right here. These two, the 5 and the 6, Roman numerals, 5 and 6, those are the only two that are in both. That's what they have in common. If I circle B, I would be circling 2, 3, 5, and 6. If I circle C, I would have 4, 5, 6, and 7. What do they have in common? They both have 5 and 6 in common. So again, you can do it the slower way too. But they hope that you can just see these. If they're unions, you want to go all the way around anything that's in either one of them. If they're intersections, it's some kind of wedge in the middle where they share. Okay, the best way to do this one I showed you last time when the camera fell, not B. Well, B is this circle right here. These four numbers, 2, 3, 5, and 6, cover them up with your hand. If you cover them up, and my hand's blocking what I can see a little bit, but it's everything out here now. So it's this 1, 4, 7, and 8 if I cover all this up. If you cover up this circle, whatever you can see remaining, that's not in B. Because B goes like this. What's not in B are these four items right out here. They're not inside of the B in any way at all. So 1, 4, 7, and 8. And you got to do them in Roman numerals when you type them in with capital letters. Okay, now they switch to numbers. Okay, so A union C, and then we want to negate that. But we'd have to do the A union C in the parenthesis first. A union C would be anything that's inside of A or C all the way around it. It's not the little wedge between them. A union C is this right here, these two circles in total. So if the question was just A union C, I would be putting 1, 3, 4, 6, 10, 11, 12, 15, and 16. Since we want to negate that and do not that, again, the easiest way is cover all those up with your hand. And you can see this 20 down here, and you can see the 7 and 8 above that. So we want everything except right down the middle diagonally like this. Everything outside of circle A and C, which is 7 and 8 that are only in B, and it's also 20 that's in none of the three. Okay, then, so similar deal. If there's three of these, let me show you this. Remember what I was doing right here? A intersection B, when there's only two circles, is this middle wedge right here. A union B is when you go all the way across all the sections of the circles. A similar deal happens when you have all three at the same time. If you have A intersection B intersection C, when there's three circles, that is this little triangular-like shape. It's not really a triangle because it's curved on top, but it's got three sides to it. That middle portion, that's when you have and, when you have intersection twice. That's the only section that's literally in all three circles at the same time. It's the only thing they have in common. If you do A union B union C, this is everything. So it's all the way around, anywhere around all the circle areas, literally every area once. You do this, 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 and this. That's A union B. A union B union C. And then just so you know, because these are going to come up too, we can also, even when there's three circles, we can do A intersection B only. We can just do those two at one time. That would be this right here in purple. A intersection B, because it looks like it does here. See, that's A intersection B here. But then if I do A intersection C, I'll do that one in green. That's right here. It's this little football wedge. And then in red, I'll do B intersection C, which is this little football wedge right here. And those are going to be useful to do as well. But this just wants A intersection B intersection C. That's literally this triangular shape in the middle, this curved triangular shape. The innermost region of all. The 16 is the only number that's literally inside all three circles. If I circle A, 16's in there. If I circle B, 16's in there. If I circle C, 16's in there. It's the only number that's in all three. If you check any other number, it won't be in all three of them. Okay, then here's the last problem of this section. It has A union B union C, and then you want to negate that. Well, A union B union C, this is anything in any of the circles. All the stuff that's circled somewhere. So it's this white region, this kind of gray area, this white region, this gray area, the blue, the gray, and the white. All of those are A union B union C. And then we want to negate it, so if you cover it up with your hand, you're covering everything but that 18 down there. So without the negation, it would have been all those numbers inside anywhere there's a circle, but with the negation, it's just 18. So notice that the last 7 problems went a lot faster than the first 8 did because we had Venn diagrams to look at. And in fact, we're going to, on the next, our final section of chapter 2, we're going to draw some of our own Venn diagrams to help make problems easier. I now have 100% on this assignment too. Okay, so final assignment of the first week. Okay, is 2.5. They're called survey problems, mostly, I guess, for the way the last couple problems go. So there's nothing new here in terms of learning new material, but what's happening is we're going to take a deeper dive into these Venn diagrams. So let's see if I can, no, that makes it worse. Okay. Okay, so they have a Venn diagram with only 2 circles, and they've labeled these section 1, which is the only A part. This white part right here that looks like a moon, that's only A. And then this one labeled number 3, the white part over here, that's only B. And then section 2 is A intersection B, A and B, and then A union B would be anything that's in section 1, 2, or 3. And then section 4 is stuff that's not in any of those. So again, a good example of this when there's 2 circles is some people have car insurance, some people have home insurance. Some people have both. Some only have car insurance, they don't have home insurance. Some have home insurance and don't have car insurance. And then some people don't have any of those insurances, or maybe they don't have any insurance at all, or just have different insurances. So that's a good example of this. And then the main difference here at the beginning of this section is they want to know how many elements. They don't want to know what the elements are. Last time we were like listing the elements that were in there. Now they just want to know how many. And I think that's what these numbers are. This is not like the last problems we were doing where they had like the numbers 4, 5, 6, and 7 in Roman numerals. This 26 means 26 of the people in the survey have only car insurance. 14 people have both, and 21 only have home insurance. 13 people have neither. So how many elements belong to set A? Remember, if it just says set A and doesn't have the word only, then you have to go all the way around circle A. So it's these 26 and these 14. You just add that together. 26 plus 14 is 40. So it's very similar to the last section. They're trying to get you to focus on one part of the Venn diagram, but then instead of listing the things there, instead of saying that it's 14 and 26, I'm combining that together and saying 40. Okay, how many elements belong to set A but not set B? So we got to cover up set B with our hand. So you can't be in set B. Now set A would have been 11 and 9, but since they put a restriction that you can't be in B either, in other words, this is what only A is about. So if you want to be in A but not B, that's the same thing as saying only A. So that's the 11 people right here. So this 11 is not just an element 11, it's like the cardinal number, the size, that there's 11 in that group. Okay, what is the number of elements in A or B? See, or is the same thing as union. I guess I should put that down here too. So A intersection B, another way to say that is A and B. And that's when you have to be in both or what they have in common. A union B, union means or. And that's one of each. So again, A and B is the middle part. A or B is when you go all the way around the circles. So you wouldn't include this 8 outside the circle, but you include everything in region 1, everything in region 2, everything in region 3, not region 4. So that would add up 29 plus 19 plus 10. So the number of, there's 29 elements in region 1, there's 19 in region 2, there's 10 in region 3. A or B wants one of each of those. So that's 58. A and B, that's what they have in common. That's when you're in both circles at the same time. That's this little purple football wedge right here. That's just 28. Remember how intersections or ands usually have a smaller answer than unions or ors do. Okay, so those first 4 are just being able to look at that and hopefully get those answers right away. The next thing is we're going to start building out the Venn diagram ourselves instead of them telling us how many numbers are in each region. Now, first they go nice on you and they tell you how many are in region 2. 16 people are both A and B. And then I got to figure out how many are only in circle A, how many are only in circle B, and how many are out here in region 4. The only information we're told is right here. The number of elements in A is 41. The number of elements in B is 43. And the number of elements in the whole universal set is 72. And then the last thing you need to know, either they have to tell you or you'd have to have some way to find it, is you have to know how much there is in the middle where they both are. 16. So to do these problems, you have to work your way inside out, actually. You got to know this middle portion first. Even if it wasn't in the picture, I'd have to figure that out first. So I got to put that 16 there. Now, when they say the number of elements in A is 41, the number of elements in set A is 41, that means all the way around A, including parts of the circle that go in other circles. So this 41 is actually this and this combined. And that's how you're able to figure it out, because something plus 16 is what equals 41. Together, these two add up to 41. So if you're looking for the something, you can subtract 16 from, it's like saying, it's like in algebra where they have x plus 16 equals 41. You're solving for x. So that's why you're going to subtract 16 from each side. 41 minus 16. There must be 25 people that only have A. So car insurance, some people only have car insurance, some have both car insurance and home insurance. And together, 41 people have at least car insurance, and maybe only that or maybe more than that, but they have at least that. And then likewise, the number of elements in B, I think that was 43, but let me double check. Yeah, 43. So that means something plus 16 has to equal 43. So if you subtract 16, you'll get how many are only in B. How many people only have home insurance? 27. So that's how you do it. You always fill the wedge in first, the ones that have both. Then through subtraction, you can figure out the two onlys. And then also through subtraction, you can finally figure out the universal part, the ones that don't have either one. Because they said the number of elements in the universal set is 72. Well, that's actually this region 1 plus region 2 plus region 3 plus region 4. All four of those sections added together have to add up to 72. And we don't know region 4, but if we add up the three regions we know, 25 plus 16 plus 27, so far we have 68 of the people known to have some kind of insurance. But there were 72 customers that they called, for example. So they had 72 customers, and they figured out 68 of them either have car insurance, home insurance, or both. So how many have neither? Because maybe they have boat insurance or motorcycle insurance or rental insurance. They could have other kinds of insurance. So that's what you do, is you add up everything inside the circles. And if you subtract that from the total, that's how many are on this outside that don't have either one of these two things. And that's how we can know each of the values of all the regions. Region 1 is 25. Region 1 has 25 elements. And they're not asking for 2 because that was given. Region 3 had 27. And region 4 is only 4 because I did 72 minus 68. There were 72 total. 68 of them landed in the circles, so there must be 4 not in the circles. Okay, so we'll be doing more of that kind of problem here real soon, actually, but I guess they switched back to something else. So number 6 says, how many elements belong to set B? Circle set B. There are 4 different regions there. There's this white region that has 2. There's this gray that has 7. This blue has 4, and this other gray has 8. So again, this is different than the end of last section. This is not saying that there's just a number 2 here and a number 4 and a number 7 and a number 8. These are the sizes of them. So there's actually 2 people that are located here. There's 7 people here, 4 people there, and 8 people there. And if I want how many people are in set B, even if they're in other sets, then you just add all those numbers together. 2 plus 7 plus 4 plus 8. There's 21 total people somehow in set B. So usually the 3 set ones, when there's an A, B, and a C, you can think of this as A is the people that like chocolate ice cream. B are the people who like vanilla. And C are the ones that like strawberry ice cream. And anybody outside the circles, they don't like any of those 3. And most people like one of those 3, so it's hard to find anybody who doesn't, but there's one person out here who doesn't like any of those 3. So the 2 is people who only like vanilla. They don't want anything else. And then the 7, these are people that like both chocolate and vanilla, but they don't like strawberry. And likewise, the 8 are the people who like vanilla and strawberry. They don't like chocolate. And then finally, the 4, this is the people that like all 3 flavors. How many elements belong to set A or set C? So you've got to keep your ors and your ands straight. If this said set A and set C, that would be that little football wedge between them, which would be 2 plus 9. The answer would have been 11 if it said and instead of or. So ands or intersections are these little football wedges between the 2 circles, depending if they want A, B, AC, or BC. So A and C would have been 11, but A or C, that's when I want to go all the way around A or C, anything that's inside any of them, even if they're in other circles. So it's actually all 6 of these numbers here, 3, 8, 2, 9, 6, and 7. All of those are somewhere in A or C. It's everything but the 1 and the 5, really. So just add that up. 7 plus 6 plus 9 plus 2 plus 8 plus 3. Because remember, OR is a union, and a union you want one of each thing. I want one of every number that's somewhere inside A or C. 35 people are in A or C. Okay, how many, see, this is what I said. How many people are set A and set C? That's easy. You just find A, you find C, and you go to that wedge that's between those two. So this little wedge that's got 6 and 8, that's the A and C. 6 and 3, that's A and B. And if you do the 1 and the 6, that's B and C. But we want A and C. That's this one that has 6 and 8. So this answer is 6 plus 8, 14. So the and is the between part. The or is all the way across when you're looking at a Venn diagram. Okay, so now there's 4 problems left. Then it's really the same problem that remains 4 times in a row. But 2 of them are done like this, where they tell you all the sections, and the other 2 is in paragraph form, where you kind of, and it's more, this is more generic and that's more specific. So this just says A, B, and C. I don't know, is it chocolate, vanilla, strawberry? But then in the last 2 problems, they're going to tell you that. They're going to tell you what they're actually about. So the key to doing these is you got to work your way out, inside out, not outside in. It's very tempting to want to just start at the beginning and use this 44. That's actually the last thing you're going to do. So just like when there was 2 circles, remember problem number 5, if there's 3 circles, the key is getting the middlemost part known somehow, or they have to tell it to me. So I know this part here, region 5, has 7 people in it. There's 7 people that like chocolate, vanilla, and strawberry all at the same time. So then what you want to do is start at the end here. See this B and C? The number of elements in B and C is 10. Well, B and C, that's this little football wedge right here. That's region 5 and region 6. So let me draw this out so we can start filling answers in. Here's circle A. Let's say that's chocolate ice cream lovers. Circle B, this is vanilla. And C is the strawberries. They gave me this 7 right here. And then, since they said the number of elements in B and C, and the intersection's another word for and, is 10. Well, I know that's this little purple wedge that I'm drawing right now. That's B and C, where they have 2 things in common. And since this is already known as 7, 7 plus something has to equal 10. So I can just do 10 minus 7, and now I know this is 3. And now I just have to do that 2 more times to get this and this next. So just go backwards. Now do this one next. A and C is 13. I'll do this one in green. A and C is known to be 13. And A's here, C's here. So these are the people who like chocolate and strawberry, only they don't like vanilla necessarily. Or maybe they also like vanilla too. But A and C, they at least like chocolate and strawberry, and if vanilla's in there, that's okay for some cases. Because that's these 7 people right here that like all 3. But that's the and is this little green football wedge. And something plus 7 has to be 13, so if I minus 7, that tells me this one's 6. So finally in red, I'm going to have I must have the A and the B still to go. A and B, they'll tell me what that is. That's this red wedge that I'm drawing right now. So going backwards, A and B is 11. There's 11 people that like both chocolate and vanilla, whether they like strawberry or not. That can be included or not, doesn't matter. But there's 11 that like both of those. And then we can minus the 7 that are in the middle that do like strawberry. So there's 4 people that only like chocolate and vanilla and they don't like strawberry. Okay, so lastly, we need to figure out this, and this. We need to know those only ones. How many people only like chocolate? They only like vanilla. They only like strawberry. And the reason you can figure that out is because now if I'm going backwards, the next one told to me is N, the number of items that are in C, the people that like strawberry one way or another, is 18. There's 18 people that like strawberry ice cream, whether that's all they like or if they don't mind the other ones. 18 total people like strawberry some fashion, which is my green one. I'm going to do green for this. This is what C they're talking about. The entire circle is 18. Is that 18? Yeah, the entire circle C is 18. The number of elements entirely in C is 18. And I already know 3 of the 4 sections of circle C. I got this 6, the 7, and the 3. So 7 plus 3 is 10, plus 6 is 16. There's already 16 right here. So if I minus 16, then there must be 2 that are only strawberry lovers. And then likewise, the number of people that like vanilla one way or another is 23. So I'll do this one in purple. The number of people that like vanilla ice cream one way or another is 23. And some of them like chocolate, some of them like strawberry, some of them like both, and then some don't only want the vanilla, they don't want anything else mixed in. So 4 plus 7 plus 3, that's 10 plus 4, that's 14. There's 14 already here. But circle B goes all the way around like this. So if I minus 14, there must be 9 that only want vanilla ice cream. Okay, finally, not finally, but now next we have the number of people that like chocolate ice cream, 25. The number of elements, whoops, I'm going to do this one in red. Number of elements in A is 25. But A goes all the way around like this because some of them like other ice cream too. So now 6 plus 4 is 10, plus 7 is 17. So if I minus 17, there's now 8 people that like only chocolate ice cream. And there's 1, 2, 3, 4, 5, 6, 7 unique regions out of those 3 circles. The final thing, which was actually the first thing they told me, is all the people in my survey, like there's 44 people total, which includes all 7 sections in the circle, plus the 8th section that they just don't like any of these 3 ice creams. Maybe they don't like ice cream, or they're lactose intolerant, or they just like a different flavor. So now we can figure that out because there's 44 total people in the survey. That's the universal set. If I add up all 7 of my sections already, 8 plus 4 plus 9 plus 6 plus 7 plus 3 plus 2. That's 39 of the 44 people. So if I do 44 minus 39, there's 5 people unaccounted for. These are the ones outside the circles, but still in the universe, which is section 8. There's 5 people out here. Okay, so now they don't want just that answer. They want me to tell them every region except probably 5, which was already known. So I'll just go look at my diagram. Region 1 is right here, 8. This is where drawing a Venn diagram really helps. This would be hard to do without a Venn diagram. Region 2 is this top part right here. In my diagram, that's the 4. Region 3 is the vanilla lovers only. That's the 9 here. Region 4, these are people that like chocolate and strawberry, but they don't like vanilla. That's these 6 right here. Region 5's known, so I don't think they're going to ask for that one. No, region 6, yeah, so now we're over here. The people that like strawberry and vanilla but don't like chocolate. There's 3 of those. Then they should ask for this region 7, the people that only want strawberry, which is 2. And then finally the 5. So only when you know every little region, numerically how many are there, then adding every region once, that always equals the sample size. But if you add A plus B plus C, that's got to be more than the sample size because some people are in more than one of these sets. So this is the exact same problem. And the only difference is they didn't put the innermost one in the picture way over here to the right that you can't even see, but way in the picture. They didn't fill the middle region in like they did on number 9, but they tell it to you right here. Remember the number of elements in A and B and C, that's that little innermost region. So that's what you have to do. You have to fill that in first. When you're doing one of these 3x3 Venn diagrams, you got to get that innermost region first, which is this 3 right here. So that's the only difference between problem 9 and 10 is 9, they just put it in the picture already, and 10, you have to understand which one of these given things here is that one. Remember, you want to work backwards. You want to do this one first. Now you want to go here next, B and C. B and C is 10, which is this football wedge. Well, let me do it on mine. This is B and C right here. So let me label this A, B, C. And I'll do this one in purple. B and C is this purple wedge right here. And they said that it was 10. And I got the 3 right there, so if I minus the innermost part, that gives me how many are just right there. And then A and C is 7. A and C is 7. That's this green wedge right here. And you got your 3 in the middle, so minus 3. This must be 4. And then they should give me A and B, which will be this red part right here. A and B. That's the next one down the line if you're going backwards. A and B, there it is, 4. And you got the 3 in the middle, so minus 3, there's 1 in this missing region. So next they're going to tell me C. They're going to tell me C all the way around. Working backwards, C has 23 in it. And I just have to minus all 3 of these right here. 4 plus 3 is 7, plus 7 is 14. So there must be 9 right here. Then they're going to tell me B next. I guess I'll squeeze it right here. B is all the way around like this. Working backwards, B is 16. And I already have a 1, a 3, and a 7 inside of circle B. That's 11. So minus 11, there must be 5 right here. And then I'll do in red A. A is 13. And A would go like this. So that's the 1, the 3, and the 4 already. That's 8. 13 minus 8 is 5. So now if I add up one of every section, there's 7 sections so far. 5 plus 1 plus 5 plus 4 plus 3 plus 7 plus 9. That's one of every section. So inside all the circles, there's 34 people, unique people. And then whatever the universal size is, I can just minus that. Minus this 34. And that's always the first thing they tell you, but it's the last thing you do. Just work your way backwards. The last thing you do is the universal, 39. There's 39 total people in this survey. And I got 34 of them accounted for in the circles, so there must be 5. Now, it's not that it's always 5, but somehow we got 5 again on the outside. But that would be the people outside the circles. They don't like any of these 3 things, whatever it's about. So now they want you to, I guess it's in order 1, 2, 3, 4, 5, 6, 7, 8. They want you to fill all those numbers in. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's the correct order. So region 1 has 5. It goes 1, 5, 1 for the first 3. 1, 5, 5, 1, 5, sorry. 5, 1, 5. Then it's going to go 4, 3, 7. It's a little more confusing here, but it's not telling. The other one was nice because they would tell me each one as I got to it. But 4, 3, 7. And then 9 and 5. This is their way of checking that you got every region covered correctly. Okay. Okay, so yeah, it's the reason there's other choices here is if for some reason all the numbers in your circle, if all the numbers in your circles added up to more than the universal, then something would be wrong. Then it would be impossible. But my universal was larger than all the circles, so I didn't get an impossible answer here. Okay, so in essence, these last 2 problems are the same thing. You have to draw the Venn diagram yourself now, is the only difference. So we got a survey of 80 college students. That's your universal right there. So when I write this down from the paragraph, this is going to be the opposite as the order I actually do. The number of elements in my universal is 80. Okay, well, how do they get their news in the world? Of those surveyed, 35 got their news from news websites. So let me just call that NW. Well, actually, I'll just call that A because it came first. So 35 got their news the first way. 27 got it from social media. I'll call that B. And 15 got it from both. So that's A and B. Both means and. And this is a problem with just two circles, not 3. Construct a Venn diagram. Okay, and then get each region. So we have a 2-circle Venn diagram. There's just A and B. There is no C. And we did this on problem number 5, actually, when it was not specific. It was just very generic. The key to doing all these is to go backwards. You want to start at the end, and that's the innermost part of whether you have a 2 or a 3-circle Venn diagram. You always got to get the innermost part first. 15 of these 80 people get their news both ways. And then there's, if working backwards, now I'm going to do the B's next. I did this one, now I'm moving to this one. There's 27 people that get their news from social media one way or another. Some only do it that way, and others do it that way plus another way. So since B, the entire circle B is 27, but we know there's 15 in the middle part, that's what you can subtract to figure out that there must be 12 the only way they get their news is social media. And then there's 35 people that get their news from websites, including some that also get it from social media. But if I subtract those 15 that get it both ways, that means there's 20 that only rely on websites. They don't look at social media for news. And then if I add all three of these regions together, that's all my circles. 20 plus 15 plus 12 is 47. I've got 47 people in circles. And there's 80 total people. So if you take the total people and minus how many there are inside the circles in some fashion or another, that's how many are on the outside. And if the circle amount is larger than the whole universe, that's an impossibility. You can't have a negative number of people on the outside. That's what would happen. If this added up to 87 instead of 47, I would have 80 minus 87 would be negative 7. You can't do that. But 80 minus 47 is 33. So there's 33 people that get their news other ways. Maybe they watch it on TV or read about it in a newspaper or magazine. They're doing it the old-fashioned way, basically, instead of with websites and social media. And that's common that older people watch their news on the TV like they used to do back in the day. So that's how you can know every section. You have to work your way backwards. From the inside out is the only way to do these problems. When they tell you 35 in A and 27 in B, that's not all of it, actually. So how many got from news websites only? They're talking about region 1 is what that is. That's 20. And then how many got it only from social media? That's region 3, actually. Because this one is the both. Region 2 is the both, and region 4 is the neither. So 12 people are getting it only from social media, which is probably bad for them. It's going to be really biased one way or the other. And then how many got it from news websites or social media? Now, this is not something that we figured out yet. What they're really asking for there is A or B. Or, remember, or is a union. And that, in a Venn diagram, that's all the way across the circles. Actually, we did figure that out. That's the 47. So the or is anything that's in a circle. And then the neither is my number down here at the bottom, this 33. They just do it some other way, 33. Okay, so I'm guessing 12 is the same thing, unless maybe this one's got 3 circles instead of 2. We got a survey of 83 college students. Okay, there's my universal. This is the last problem. Okay, the universal set is 83 this time. So there's going to be an A and a B for sure next, and maybe even a C. So 32, listen to techno. Techno is going to be A for me, since whatever comes first, I just call that A. 32, listen to techno. 28 to hip hop, that's going to be B. And 28 to rap. See, this is one with a C also. But this will end up being like problems 9 and 10, except we have to draw the diagram ourselves. Okay, 15, listen to techno and rap. Now you got to be careful what the order there is. Techno is A, rap is C. So they just gave me A and C right there. That's the 15. 14, like techno and hip hop, which is A and B. Got the number now, 15, 14, okay. So then there should be a B and C, should be the next one, since that's the only one I don't have. That's the 10. There's 10 that like hip hop and rap, which is the second and the third one. Finally, 7 students listen to all 3. See, that's the one you got to have first, even though it's given to you last. There's 7 students that like all 3 of these at the same time. This is the triple and. That's the middle, the most innermost portion of the 3 circles. So get your A, B, C circles going in a Venn diagram. And just go backwards. Start down here with this 7. That's the innermost region. Okay, if I want to do this 10 next, 10 is B and C. So circle that football wedge. That's this wedge right there. And it's got to be 10 minus the 7 in the middle. That's 3. Now do A and B next in green. A and B is this football wedge. And it's 14 minus the innermost one of 7, which is 7. Finally, A and C, that would be this football wedge right here. A and C is 15, so if I minus the innermost 7, that's 8. So then let me go back to purple. There's 28 that are all around C. If I go all the way around C, there's 28 total in all 4 of those parts, and I know 3 of the 4 parts. 7 plus 3 is 10, plus 8 is 18. So 28 minus 18 would give me this 10 that only like the third music, rap music. And then B I'm going to do in green. B goes all the way around like this. And I already have 10 plus 7. I already have 17 inside that circle, and there's 28 total. So that leaves 11 that only like hip-hop music. And then finally, circle A I'm going to do in red. Circle A's got 32 total students, but there's already the 7, and the 8 in that circle. 14 plus 8 is 22, so then subtract 22 from 32. There are 10 that only like techno music. So if you add up one of every section of those 7 sections, that's always the A union B union C, and they asked for this on the last one, so I'm going to do it now. If I add up all 7 sections inside the circles, 10 plus 7 plus 11 plus 8 plus 7 plus 3 plus 10, there's 56 people inside the circle somewhere. This is when you have all union, A, union B, union C, because that's when you go all the way around the circles. And this number better be less than the total in the universe. Otherwise, then that's how you would get those impossible answers that we saw earlier. So this is not an impossible answer. I still have some people left over. So the universal set actually goes like this. And then we have this 8th region down here. These are people that just don't like any of these 3 kinds of musics. And that's, you get that by doing the universal size 83 minus all the people in the circles 56. There are 27 out here that like either some other music or don't like music at all. And now we got to see what they want for answers. Okay. Only techno is this 10 right here. That's only A. Hip hop and rap, but not techno. Okay, this could be confusing. Hip hop and rap, but not techno. In other words, not circle A. If I cover up all of circle A, how much is left in the B or the C circle? There's 11 plus 3, 14 plus 10 is 24. So that's not normally one that's one of the regions that we get, but you can get it by covering it up. Oh, wait. How many listen to hip-hop and rap? Oh, and maybe the and matters. Okay. And. So let me do that again. Not techno. See what I did? I just did B or C by getting this 24, but they said and. So it should just be this 3 right here. That's why you got to pay attention to the ands and the ors. It makes a big difference. There's only 3 that are in both of those. So, see, here's the or. This is what I actually answered. So this should be the 24 because I just did it accidentally a second ago. I wasn't paying attention to ands and ors, and I made the wrong assumption. How many like exactly one style? So that would be this 10, this 11, and this 10 here. These are the ones that are in the only sections. 10, 20, 31. How many like exactly 2 styles? Okay, exactly 2. Okay, so I'm not sure what this would be. Actually, exactly 2. So I think that's everything except for the one where there's 3. The innermost part is where they all 3 of them are liked. And this is where none are liked, so it's not going to include that. But no, I know what it is. It's this, this, and this. Because these are when they only like one of them. So it can't be these 3 either. It should be this 7 plus 3 plus 8. That should be 18. I had to think about that for a second, but 18. And how many like none? That's easy. That's the bottom one down here, 27. So some of these were kind of hard actually, but that's an easy one, 27. But all of these would be very hard if you didn't draw the Venn diagram. That's the whole point, is the Venn diagram makes this a lot more doable. Okay, now we have 100 on this section too, and now we finished all 8 assignments that are due this week. So if you're watching this on Thursday, July 20th, then, and if you're keeping up with the homework every day, 2 sections per day like I did, then you may be like me, and you may have, for all these first 8 right here, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. All 8 of those are due Saturday night, July 22nd, 11:59 p.m. And even if you have 100 on them all like I do, 100, 100, 100, 100, 100, 100, 100, 100. So if you get 100 on all 8, then your homework average for the first week will be 100. Otherwise, I'll add them up and divide by 8. That's 10% of your grade. If you send me the 4 magic words for this week, then you can get another 100. And then you have a choice now. Well, for the next 2 days, you should be reviewing and studying and or working more homework if you want. You can always do the homework more than once. So you got till Saturday night to finish up homework and take the test. The test will appear right here between review week 1 and review week 2. It'll appear there tomorrow. Starting Friday morning, it'll appear, and it'll be visible for 2 days. But you only get 1 attempt. So if you finish all the homework like me and you just want to study and review, there is no review for this test directly, but you can either work any homework problem again. Even if you get them right, you can just hit give me another one, or I forget what they call it, try another, or similar exercise, I guess they call it. You can always do that. You can always hit similar exercise and do any problem again if you want. If there's anything you feel you didn't understand. And then you can even do this review if you want. It's not due right now, and we're going to have a video for it later. But you can do it now because you can always do it again later. So if you really want something to use to review other than the homework, then you do this review, and you don't even have to do it all. Just do as much as you have time for. But even if you do it all, and then we're going to use it again to review for the final, you can do it a second time while you're reviewing for the final, because 4 weeks from now, you'll probably forget it all anyway. So that's a good thing to use, and it grades it for you. There's nothing in this review that isn't in the homework somewhere. So we've already covered it all. I just created this as a way to have something to review the final week, because it'll have been a while since you've seen it. So you don't have to do the review right now. You will have to do it eventually, but you don't have to do it right now. But you could use that to help study for the test, unless you just feel this is easy and you're ready to go on the test right away. But that's the worst thing you can do, is just, oh, this was easy, and then take the test Friday morning and get a bad grade, because then there's no recovering from that. I mean, it's not that you're going to fail, but there's no way to do anything about that test grade once it's taken once. So I sometimes get people, they take the test, they get a bad grade, and then I look and they don't have 100 on every homework. They didn't even try the review. They just rushed into it a little too quick. So hopefully most people don't do that, but a few people do. Okay, so this is the end of week 1, and next week we'll be continuing on into chapter 3 next. Good luck on the test, whether you take it tomorrow or Saturday.